We've been talking about y equals mx plus b in a function, and what we're going to look at today is what exactly that b value does. So if we look right here, it says a vertical translation f of x plus d. This plus d is the same as our b value of a graph shifts the graph up or down. And we know that because our b value, if it's like a positive 3, we know we go up 3 from the origin. If it's a negative 3, we go down 3. And we're going to look at how, even if it's not linear, whatever's added or subtracted as the constant, meaning the one without the variable, will move a graph up and down. So they give us this funky graph, g of x. It's not a graph that we would normally write an equation for. But what they want us to do is it says g of x plus 3. Well, this is saying that we are going to have to move everything up 3. So this particular coordinate, which was at negative 3, 0, is going to go up 3, 1, 2, 3, and it's going to end up being at negative 3, positive 3. So I'm going to put a dot on my new graph there. That's a little bit light. Let me choose a darker color. So we've got this right here. We have this coordinate here, which is at negative 1, negative 3. So if we're at negative 3, we're going to go up 1, 2, 3. Here's my new coordinate. I'm just going to erase my line there. Then we have a coordinate at 0, 1, so I'm going to move that up 3, 1, 2, 3, so now it's at 0, 4. I've got 1, 0, so I'm going to go up 1, 2, 3. And then I also have at 3, 0, which is going to go up 1, 2, 3. And now I can draw my new graph as it has shifted. And then there's a loop there. So what I've done is I've taken this graph and I've moved everything up 3. I've even moved up, this was at 2, 1, so I went up 1, 2, 3, and I can put a dot here. So I would like you to try at negative 3. So think about what minus 3 is going to do based on this original graph. So if you'll pause me, I want you to try it and then come back. We'll come back. You should have realized that everything is now moving down 3. So we were at negative 3, 0, so now it's going to be at negative 3, negative 3. Oh, I hit the wrong button. Let's bring that back. There we go. Negative 3, negative 3. And then negative 1, negative 3 is going to go down 3 more. So negative 1, negative 6. I've got, I could even go ahead and connect those. I've got 1, 0 will go down to negative 2, 0. I've got 1, 0. 0, 1 went down to 0, negative 2. 1, 0 is going to go down to 1, negative 3. 2, 1 is going to go down 1, 2, 3 to 2, negative 2. And then 3, 0 is going to go down to 3, negative 3 to make that little loop. So think about these questions and how you did there. How did the values of g of x plus 3 change from g of x? So all y values added 3. So versus how did the values of g of x negative 3 change? Well, then all y values minus 3. We did not label our y-intercepts on this previous graph, so I'm going to go back, I apologize, and do that. So the y-intercept here was at 0, 4. Y-intercept here was at 0, 1. And the y-intercept here was at 0, negative 2. This also asked for max. The max is also going to be the y value of negative 2. We've now circled all of the y-intercepts in the table. How did these changes match the movement? Well, they went up or down 3. according to what we had. And we can see this transformation if we make this little table. We said -3, and this is our original, because it says g of x, -3, 0. -1 was at -3. We were at 0, 1, 1, 0, and 3, 0. And remember, this means that our y's were +3. So if we look what happened when we added 3, well, it's still at -3, but now it's at -3, +3. It went from -1, -3 to -1, 0. 0, 1 went to 0, 4. 1, 0 went to 3, 0, 1, 3, and then 3, 0 went to 3, 3. And the same thing with the minus of the 3. We went, instead, these y values here, they -3. So it was -3, -6, -2, -3, and -3. So keep in mind when we are adding and subtracting this constant term, that means that we are moving up or down. Now, what happens to move left and right? So this is a horizontal translation. Think of it, it says f of parentheses x minus c. Now, this, because this is in parentheses, that is your clue that this is a horizontal shift. So parentheses equals horizontal. So you could, think of it as a pancake, and it's going all together. So this x minus c, because it's in the parentheses, tells you that this is going to be on the x-axis. The other thing you need to remember is that it says here insiders lie. So even though if it's -3, that means we're actually going to go to the right. 3, if it's a +3, we're actually going to go to the left because insiders lie. Because our original equation says the opposite of whatever this constant value is. So again, we have this same graph here. And we've got, it says now x minus 3, and it's in parentheses. So this is not an up and down shift. This is a left-right. So I was at -3, 0. Now I'm going to go 1, 2, 3. Here is my new coordinate. I was at 1, -3. I'm going to go 1, 2, 3. I was at 1, 0, 1. I'm going to go 1, 2, 3. 1, 0, 1, 2, 3. Oh, am I doing this right? Let's think about this. It says insiders lie. So am I really doing this right? Let's think about that. No, I'm not, because this is the common mistake that's made. This actually means right 3 because of the insiders lie. So let's try again. Hopefully you're using your pencil. So try again. -1, -3, we're going to go 1, 2, 3. -1, -3, 1, 2, 3. Keep that in mind because that is the most common mistake we make here. 1, 0, 1 is going to be 1, 2, 3. 1, 0, 1, 2, 3. And 3, 0 is 1, 2, 3. And we can draw our new graph like that. I will go over it in a different color. So we took this whole graph and we shifted it just to the right 3. Now this one, we're going to go left 3. So I'd like you to pause me and try that. Hopefully you're done now. So you said, okay, I was at 3, so I went to the left. -3, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So hopefully now your graph looks something like that. So if we were to complete this table, we're going to see what happens. So if it was at negative 3, and then we said, okay, we're going to say 0 minus 3, because that was our x value. Then g of negative 3, we ended up at 0. These tables get a little confusing. We're not actually going to look at this. Let's come down here. How do the x values of negative 3 change from g of x? We went a right 3 shift, and plus 3 we went a left 3 shift. Now this says the x-intercepts. Alright, so keep in mind what an x-intercept is. It's where we cross the x-axis. Remember, we have new vocabulary for that. This actually crosses the x-axis at multiple places. This is still a function because it does pass the vertical line test. Right? So our x-axis is, or our x-intercepts simply move. We're going to do it in the graph there. How do these change match the movement? Because our x-intercepts changed by 3. Tomorrow when you come into class, we're going to do a little more practice with this, and we're going to combine them. I hope you have a good night.